Now, in our previous lesson, we talked about what a function is. We looked at the various types of functions, which I said we shall be taking them one after the other. We will look at the various types of functions. But this time, we are going to look at how we can evaluate a function when a function is given to you. Okay, so let's look at what is here. We have a function f defined by f such that x maps onto x squared can be written as f at x, or f of x is equal to x squared. So in a question, when you are given this notation, to evaluate a given function, you can write it in an equation form. Because this one is not in an equation form, we have been given this as a mapping form. Looking at this arrow, this is a mapping form. In that case, this is a relation, and this is also a relation, but this one is in an equation form, while this one is in a mapping form. Okay, so when it's given to you in a mapping form, all you need to do is to write the equation form. Okay, all right, now let's look at the various things here. Okay, what is given in the relation here. So when we say when we see f of x or f at x, what does it mean? We are saying that f at x, or f of x, yes, that's how we pronounce this. Okay, we say f at x, or you can also say f of x is the functional value of x. So when you are asked to evaluate whatever value you be given as your x, when you substitute and work out the answer you get here, that is f of that value. Okay, it gives you the functional value of x. It gives you the value for this one. Okay, it can also be called the image, or the corresponding value of x. That's what we are saying. Okay, so whatever answer you get for f at x, the f at x is the functional value of x, or also called the image or corresponding value. We can also call the same thing as the range. Okay, yes, the range of a function. It can also be the range of the relation or the function. Okay, and what is this x? This x you see in this bracket, what is that? So we are saying that the x here is an element of the domain. So this x is whatever element you pick from the domain. Okay, so that is what the x represents, and it is coming from where the x-axis. Okay, it's an element of the domain, which is x-axis. And what about this one, the x squared? So we are also saying that the x squared is the image of the x under the functions. Okay, under the function f. So the x squared can also be the same as this, because at the end of the day, when you substitute the value of x into the relation and solve, whatever answer you get here, that gives you the functional value. So this you see here is an image. At the same time, it is also a functional value, as this. It's also the range, and also an element of the codomain. So while this is an element of the domain, the value here, the x squared, is also an element of the codomain. So know the difference. All right, so that when the question is given to you, you'll be able to know what you are writing. Right, without wasting time, let's look at, or let's take an example. So we are going to use the same relation. Given this relation here, if you are asked to let's say you are asked to evaluate this f at a, evaluate this. What does it mean? It means that this a you see here is a value of the domain. Okay, it is an element of the domain, and we have to substitute this a for x. We are going to substitute the a for x, meaning that wherever we see x in our relation or our function, we put a there. All right, good. So since we have this as our relation, which is f at x, which gives us what? X squared. The only thing I will do is, that means the a represent what? Where the x, this x is equal to what? My a, whatever given to you. Okay, so I'm going to substitute this. I'm then going to have f at a is equal to what? A squared, meaning that they said I should square what? The x value. And what is the x value? A. Okay, so this answer you have gotten here, this my f at a is what we call what? The functional value of a. This is what? The functional value of a. And this a squared here is also what? The image or the range or the functional value, okay, of a. All right, so this a here is an element. All right, now let's take real examples or other examples and look at how we can evaluate them. All right, okay, great. So let's take this example and see, given that f such that x maps onto 3x squared minus 2, find I f at negative 3, I f at b plus 1. So like this example, how we solve it, we are going to do it the same way. Okay, all right, so if that is the case, then let's begin with our solution. Good. Now I told you that when it is given to you, this is what? A relation or a function given in a mapping form. When it's given in this form, you need to change it to what? An equation form, so that you can solve it. So this one can be written as f at x, which is giving us 3x squared minus 2. Okay, now considering the first one, which is I, where we have f at negative 3, it means that my x is equal to negative 3, and that means wherever I see x in the relation or in the equation, I will just substitute with negative 3. So that is what I'm just going to do. Okay, through this one we are just evaluating. Okay, all right, so we have f at negative 3 should be equal to this 3 here, open bracket, then put negative 3 there and square it, because it says we should square what? X, then minus 2, which gives me, so anytime you are doing such example here, what you do is you have the square here, deal with whatever is in the bracket, deal with the square first, square whatever is here first before you multiply. Most mistakes that students do is that they don't square this first. They will rather multiply this by this and get what? Negative 9 before they square, which is very wrong. So what you need to do is that just take what? The square of this. Okay, after getting the answer, then you multiply by the 3. So what is negative 3 squared? So I'll write my 3 here and then square this, and this becomes what? Positive 9 minus 2. And what is 3 times 9? It gives me 27 minus 2, which finally gives me what? 25. Good. So this gives our answer. It's very simple, right? Great. Now let's look at the 2, the example 2, that is the II. The II also asks us to evaluate f at what? B plus 1. It also means that my x value is given as b plus x. That is, wherever I see x in the equation, I put the entire b plus 1 there. So that is what I'm just going to do. All right, great. Plus 1, which is equal to, I have my 3, I open brackets and put this here and square it again. That is what this demands. Okay, minus 2. All right, so let's move on. Okay, as I said, always deal with this first. Okay, so to make it simple for some of you, just maintain your 3. Then if you see this, now note that if I have 2 squared, this is what it means. It means that 2 times 2. 2 is multiplying itself how many times? 2 times. So it means that this plus this all squared means that it is multiplying itself how many times? 2 times. So I can do this b plus 1, which is multiplying itself how many times? 2 times. Then I'll bring my 2 here. Then this you have here, you need to open the bracket. And remember what we did in GHS, that is what? Expansion of bracket, algebraic expression. So let's do that here. Okay, when you are given such, if I give you x plus 1 to expand, that's x plus 1 to expand. We know that you pick this x will multiply what? The entire expression here. So it will be what? X plus 1. Then I will take this 1 as well and also multiply by this entire expression, which is x plus 1. Okay, great. So where I can multiply this as x squared, this by this as what? My x. Then after that I will also multiply this, which I will get x. This plus this will give me what? 1. Then I can add what? Like terms. This and that are like. Remember this and that are not the same because of what? The exponent. You have exponent 2, or the degree here is 2, here the degree is 1, so they are not like terms. So you can't add all the x's. You add those that have the same degree, okay, or the same exponent. So I will maintain this and add this to this, which will give me what? 2x plus 1. So we are going to apply the same method here to do that. All right, great. So if that is the case, then I can maintain my 3 here, open bracket. So this b is going to multiply these b's how many times? So this times this gives me what? B squared. This b will multiply this 1, which will give me what? B. This 1 will multiply this b, which will give me what? B. And this 1 will multiply this 1 and also gives me 1. Okay, minus 2. Then I need to deal with this bracket. Okay, so I'm going to have 3 out, then b squared. I can add this because they are like. So I can get 2b plus what? 1 minus 2. Okay, then once I'm able to get this, I can go ahead and do what? Open the bracket, okay, by multiplying 3 by each term. So 3 times b squared gives me what? 3b squared. 3 times 2b gives me what? 6b. And 3 times 1 gives me 3 minus 2. Since this and that are also like, I can finally write my answer as 3b squared plus 6b plus what? This minus this gives me 1. And this gives our answer. Very simple, right? Great. So when we ask you to evaluate or find the values of this, that is what we mean. Okay, it's very simple. All right. Okay, so we shall end here and continue next time. Now in our next videos, we are going to look at a one-to-one function. That is a type of a function. Okay, we have already mentioned the types of a function. We shall be looking at one-to-one function, how we can prove one-to-one function both graphically and algebraically. All right. Okay, so this is Mathswiz TV. I'm your facilitator, Evans Okine. Don't forget to subscribe, like the videos, and share. See you next time. Bye bye.